All right, so we got our hands dirty with one production scene. We have a few more coming along the way. But for the moment, I wanted to take a video to take a break from the production stuff and go over some of the more technical stuff of mental ray. So this is what we're going to do. I'm not even going to open up a new scene or anything. This is a new scene, but I'm not going to do anything special here. All I'm going to do is over here in the render main toolbar under the render section, I'm going to go over here to render and go to renderer options. And the default renderer of XSI is mental ray. So here we have our mental ray options, and we have many tabs. Right now what I'm going to do is try to demystify some of this stuff. I'm not going to go into it too much into detail, mainly because first of all, it would take too long and you'd probably fall asleep by the time I get to the second or third tab. The second reason is I've already covered this stuff in pretty good detail in the Introduction to Mental Ray tutorial available on our website. Since this is a more advanced and intermediate tutorial, I just wanted to go over this as a refresher and go over it not in too much detail, but maybe cover some of the new stuff. That way you can see what's new. For example, Radiance Particles is not available in our Introduction to Mental Ray tutorial because that was done with an earlier version of XSI, which was XSI 6. Since this is XSI 7, I thought it was appropriate to come in here and talk about these new tabs, like say the new Ambient Occlusion tab, the Photon Global, Radiance Particles, so on and so forth, as well as some new options that are available for final gathering and different things. Okay, so the first thing we'll do is start with the rendering tab. Under primary rays, we have a type, which is we have scanline, ray tracing, rasterizer. Ray tracing gives the most realistic and physically accurate results, but it's the slowest to render. I would stick with scanline for production. Scanline is a faster rendering algorithm than ray tracing. It's less realistic, but in all honesty, most people with the naked eye can't tell the difference between a ray tracing scene and a scanline scene. So I would stick to scanline to be able to render a lot faster. The rasterizer is a pretty fast rendering algorithm that comes with its own quality options, as you can see when I switch to it. But it's only really good and only speeds up rendering if you're doing something like heavy motion blurring. The rasterizer is very good at rendering out motion blur fast. But I would stick with scanline because it's a good balance of speed and quality. Alright? So you don't want to compromise that too much. So stick with scanline, you'll be fine. Then we have aliasing parameters here. Aliasing controls directly the quality of the render. The minimum level controls the minimum level of anti-aliasing rays that are shot out when you render. The less minimum level you have, the lower quality the render. The higher the max level is over here, the higher quality the render. Okay? Now you want to be careful. You don't want to set this to say 1 in 1 or 2 in 2. Never set these two parameters at the same exact level. Very bad thing to do. For testing and test rendering, you want to go with something like maybe -1 and 0, or maybe even as low as -2 and 0, but you don't want to go much lower than -2. And you don't want to go higher than 0, or else you're going to have longer render times, and that kind of defeats the purpose of preview rendering fast. When you want to do production render, I recommend going with 1 and 3. If that's taking too long to render, however, you may want to stick with 1 and 2, as that'll still render at a pretty good quality and faster. But if you don't want to compromise quality too much, I would stick with 1 and 3. Down here under sampling contrast, we have this sampling contrast parameter, which allows us to tell mental ray when to use the minimum level and when to use the max level. So essentially, areas that are high in contrast are going to get a lot of anti-aliasing. Areas that are low in contrast are going to get less anti-aliasing. This is a very good optimization trick for getting mental ray to put more effort into quality in areas that need it, and areas that don't need a lot of quality and already look good will either be ignored or won't receive as much attention, which is a good thing because it saves you a lot of rendering time. If it wasn't for these settings here, especially the sampling contrast, your renders could take a very long time to complete, which wouldn't be good. For production, I would stick with a sampling contrast of something like 0.05 for all of the channels. However, in some cases, this could slow rendering time down, so it really depends on the scene that you're doing. If you're doing a scene with a lot of contrasting colors, a lot of light and dark colors very close to each other, then you might want to stick with maybe a little bit of a higher contrast so that your rendering doesn't take too long. If you're doing a scene with a little bit of contrast, not too many contrasting colors, like let's say a light blue and dark blues all over the place, you don't want to increase the sampling contrast to something like 0.2, because then you're going to take a little bit longer to render than you would like. Just below that, we have the motion steps parameters, and we have two: transform and deformation. This is directly used when you're using motion blur with XSI and mental ray. The transformation or transform parameter controls the amount of steps or interpolation when mental ray is trying to calculate motion blur based on transformation. Say if something is rotating like the propeller of a helicopter, or something's moving really fast like a rocket or something. If you're seeing that your motion blurred results aren't looking too well, increasing the transform motion steps will definitely help out the motion blurred results. Of course, keep in mind that the higher or the more number of transform motion steps you use, the longer the render is going to take, but the higher quality the motion blur result is going to be. The default setting is 1. Deformation motion steps works the same way, only this works for animated deformations. Let's say if you're doing any type of animated deformations on a character or on some kind of object whose motion blur is being calculated based on deformation of its geometry. The more steps you have, the better quality the deformation motion blur is going to have, but the longer it's going to take. So stay aware of that. Down here under enabled features, we can change the different enabled features we can use. For example, we can have mental ray ignore lens shaders by turning off the lens shaders parameter. We can also turn off volume shaders by just unchecking the volume shaders parameter right here, and mental ray will ignore that at come render time. So it's pretty straightforward and simple to use. Let's switch over to the next tab, which is optimization. In optimization, we can choose the render type. For example, we can tell mental ray to render out a full beauty pass where everything is rendered out. That's the default setting. We can also tell mental ray just to render out light maps. In case you're doing any type of texture baking or light mapping, you can use this feature just to render out light maps and not waste time rendering out the whole scene. You could tell mental ray to render out final gathering only, or to render out the photon or a radiance particle maps only. That way, if you're trying to do any type of indirect illumination calculations, you can just get that out of the way and skip all the other rendering so you can get your work done faster. If you have a scene that's extremely heavy, you have lots of objects, lots of polygons all over the place, and you want to go ahead and optimize it, you can click this optimize button here, which is for heavy scenes. And if you click on that, you notice that my parameters all changed and adjusted in preparation for a very heavy scene. To go back, you can just click on the set defaults button and everything goes back to default. Here we can also change the primary rays. Just like back in the rendering tab, it's just another place where you can switch that same parameter. So you can switch from ray tracing, scanline, and rasterizer. Alright, we can also set a memory limit for mental ray. By default, it's turned on and it's set to just over a gig. Okay, it's very important to have a memory limit just in case if you're having problems with mental ray and it's crashing or things like that. You can set a memory limit. The default is to have a memory limit. I recommend you keep it on. Keeping this memory limit on will allow you to render with mental ray more stable and stay away from crashes or running out of memory, things like that. If you're going to be rendering out reflections or refractions, you need to use secondary rays, which are turned on by default. If I turn them off, you won't have any reflections or refractions in your scene, which could be the case if that's exactly what you're going for. In some cases, in a lot of cases, you may want to have reflections in your scene, in which case you may want to leave this secondary rays enabled. For the reflection parameter, we can set the number of reflections that we need. By default, it's set to 5, so there'll be 5 reflection rays that branch out in your scene. This allows you to set an upper limit to the amount of times that a ray can reflect or refract. So they work exactly the same, only this one up here works for reflection, this one down here works for refraction. And down here we have a combined value for setting an upper limit for the total number of ray bounces in the scene, which combines the reflection and the refraction. So it's very important to have these limits so you don't have, say, reflections calculating infinitely, which would be a problem. Down here we can change the tile order to two different tile orders, the Hilbert tile order or spiral. The way this works is pretty simple. Um, Usually the preferred method is to use Hilbert, but you could use spiral. Hilbert is going to work based off of a Hilbert curve, which is the preferable tile order for rendering. You can also use spiral, which is going to go ahead and render from the center of the image and work its way outward in the form of a spiral, hence why it's called spiral. I would keep it at Hilbert at all times, as that seems to be the best and most preferable tile order for rendering. We can also set the tile size because Mentor renders in tiles. We can set the tile size to automatic, or we can set the number of pixels for the tile size, 4x4, 8x8, 16x16, etc., etc. I will leave it at automatic, which is just fine. Then down here we can set the visible geometry side. So we can set Mentor to render out either both sides of a polygon face, or just the front, or just the back. By default, it's set to both. This option down here for sampling displacement before rendering is automatically activated by default. It actually helps Mentor to calculate displacement a little bit faster, so it can help boost rendering speed when you're working with displacement. So I would keep it on. The shutter settings down here are tied in directly with motion blur, so I'm not going to go over them right now since we're going to talk about them later anyway when we cover an area of this tutorial that goes over motion blur. Down here we can see we have this option for convert textures to memory maps. Memory maps are a great feature of Mentor that can help you save a lot of rendering time as well as memory. This is the way they work in a very, very simple way of explaining it. When a texture is memory mapped, what that means is that it'll never be loaded into memory by Mentor, so it won't use your system RAM. Instead, the image is accessed directly from the hard drive disk, wherever you have it on your computer or your system, whenever a shader needs it for rendering. So if you have, for example, a very heavy scene with lots and lots of textures, and you're running low on memory, or you just don't want to use up your system's memory, you can convert the textures in your scene to memory maps for Mentor. That way Mentor will just access them from the hard drive as opposed to using up your system RAM to load up a large texture. And this works great if you're using a large texture, like let's say a 2K texture or a bunch of 4K textures, and your system is chugging or simply won't render because there just isn't enough RAM to load up all those high-res images and textures. You can use this option here to never load those images to the RAM. Just access them straight from the hard drive. So it's a great feature in Mentor to optimize the way that you work with textures. Over here we have the frame buffer tab, and over here we have a few settings. I won't go over every single setting, I'll just go over some of the most important ones. Up here we have a filter for our sampling, and we can choose different filters. The box filter is the fastest to render, but it doesn't look that great. For production, I would stick with a Mitchell filter. That's what I like to use, and a filter size of 4. Works out pretty good. Alright, so I'm just going to go ahead and skip all this stuff here and move on to the next tab. Shadows over here, we can choose the different types of Raytrace shadows. So we can choose segmented shadows, sorted, enabled, or we can disable shadows entirely. Setting this option to enabled tells Mentor to create regular Raytrace shadows. These are just regular basic shadows that Mentor will go ahead and calculate. If we switch over here, we also have the sorted Raytrace shadow type. Unlike with the regular shadows, which is just the enabled option, which calls up shadows in a random order, the sorted method actually brings them in a more sorted order. Basically, the way that it works is that the object closest to a point of illumination is brought up first. That shader is called up first, and the object that's closest to the light, any object that's closest to the light, has its shadow shader called in last. So it goes in that order, from farthest away from the light to closest away to the. Wait, never mind. Hang on. Okay, I didn't make a mistake there, but it's just There's really no point to explaining this. It's just plain semantics. I'm just going to regurgitate the explanation for the Sordid method again. Starting again in 3, 2, 1. The Sordid method instead goes ahead and it calls the shadow shaders in a specific order that Mentoray will use. So the main difference between these two, really there is no main difference except that the Sordid method, Mentoray will use a specific order to go ahead and call up the shadow shaders. And the regular enabled mode, which is regular Raytrace shadows, the order of the shadow shaders is called up randomly. And really there's no main difference in terms of rendering speed here. You can use enabled or Sordid. You're not really going to see much of a difference if at all. Now segmented works a little bit differently. Segment renders out slower because of the order that the shadow shaders are called up. But what are the benefits to segmented shadows? Well, because of the way that they're calculated in the order that the shadow shaders are called up, you need segmented shadows to be able to create appropriate and correct shadows for volume effects. So if you're using any type of volume effects and you want them to render out correctly, the shadows at least, you're going to have to switch to segmented. I'll just leave this on enabled, regular shadows. Then down here we can activate shadow maps. We can deactivate or enable shadow maps. We can also turn on shadow maps for motion blur, and we can tell shadow maps to rebuild at every frame. By default they're all turned on. My suggestion, my recommendation, leave them on. The default settings are pretty good. Then we have this new tab here in exercise 7 with Mentoray 3.6 called Ambient Occlusion. Ambient Occlusion can now be controlled at a global level. As you can see here, we can disable Ambient Occlusion or enable it. By default, it's enabled. However, in a new scene, you won't see any Ambient Occlusion unless you plug in the Ambient Occlusion shader. And we'll have a look at that later on in another video during this tutorial. We'll actually go over ambient occlusion and we'll work with ambient occlusion in an actual production scene to see how it works. And you'll get to see better how this ambient occlusion tab comes into play. Then final gathering, you'll see that we don't have anything. We'll enable it and now we have all these options. There's a whole host of options here. Now, from Mentoray 3.5 to 3.6, there really weren't a lot of changes made to final gathering, except probably just one main change. If we go over here to the accuracy mode, the new accuracy mode that was introduced in this version of Mentoray in exercise 7 is the exact mode. And we'll talk about exact mode when we cover final gathering in this tutorial. But for right now, we have all these different options for optimizing and changing the look of final gather, and we're going to go over that a lot and pretty heavy when we get into final gathering. And then GI and Caustics over here, we can turn on global illumination, which has been in Mentoray for a pretty long time. It's pretty standard. Hasn't really changed much from previous versions of exercise 7. And then we have Caustics, which also is a pretty old feature of Mentoray and hasn't changed much since the previous versions of exercise before exercise 7. Then we have this Radiance Particles tab. This is new in exercise 7 with Mentoray 3.6. Radiance Particles is a brand new indirect illumination algorithm that we can use. So we have final gathering, global illumination. Now we also have Radiance Particles, which works a little bit different in some ways and a little bit similar in other ways to global illumination and final gathering. And we'll have a look at that in another video in this tutorial. You'll also notice that it's grayed out and we can't select it. We'll talk about that later and you'll learn how to activate it and use it in a future video. Then we have the Photon Global tab, which is also new in Mentoray 3.6 for exercise 7. And over here we can switch our indirect illumination algorithm from global illumination / final gather, which was the default indirect illumination algorithm in previous versions of Mentoray. But now we can switch to Radiance Particles, which, as I explained a few seconds ago, is the new indirect illumination algorithm in Mentoray 3.6 for exercise 7. And we'll talk about that in more depth a little bit later. Then we have Diagnostics Tools, and the Diagnostic Tools for the most part are pretty much the same as before. They really haven't changed, and they allow us to see different types of information and log messages and things that give us warnings or errors or even progress or just simple information about our render with Mentoray. Then we have MI archives, which we're not really going to talk about during this tutorial because we're not going to be exporting any type of MI files which you would use to render out with Mental Ray standalone. And the Mental Ray standalone version is a completely different software that really has nothing to do with XSI. It's from Mental Images, and you purchase it separately, and you can use it on a render farm to render out Mental Ray files like these MI archives that we can actually export out. Okay, so that's a quick overview of all these tabs and render settings for Mental Ray 3.6. Most of the stuff is pretty old and was covered before in our Introduction to Mental Ray tutorial, but some of the tabs are new, and you'll get to see how to work with them a little bit closer and more in depth in videos coming along down the road in this tutorial. Okay, so that's going to cover it for this video. I'll see you in the next one.